Problem 14 states, given the following code segment, select the best description of what the code does. So in this code, we have a standard bit set that is called by reference, which we call unsigned bits. And we've templated to size t bit set. So the number of bits in the bit set is in this template. Furthermore, we return an unsigned integer and we pass an unsigned int num to this result. So let's check what we do. We have value equal to 0 and unsigned int mask is equal to 1. So we're iterating from 0 to the bit set size and I++. So what's happening here is mask has a bunch of zeros. What's going on underneath the hood in the unsigned mint is it's going to be initially a 1. And we AND it with the value of the mask. When we say that num and mask equals 0, that means none of the bits are the same, which means that here, if we have a 1 and we have a 1 here, and they match, that means we put a 1 there, and the rest of them will be zeros. So that's what's going to be returned in the result. If none of them match, if they're all zeros, then it's going to be 0. If we have a 1 here, we compare this 0 and 1 is 0. So the only way this could possibly not be 0 is if the bit that it's located at, and they're both 1 and they match. So in this case, if it's not 0, that means we have a match at that particular bit. And then we put unsigned bits I is equal to 1. Now the crucial thing to think about how we can read from left to right and how the bits are stored from left to right is that if we put I is equal to 1, when I is 0, it's actually going to put 1 here and have all the remaining bits over this way. So if it's done like this, what we're actually doing is we're reversing the order. And this is confirmed because value plus equals, which we initially have as 0, is unsigned int I pow of 2 to the 31 minus I. So if this is 0 for I, then this is actually going to be 2 to the 31 that's added. So what we're actually doing here is we are obtaining the reverse of the bit representation of num, and we're actually getting the value. So we're flipping the bits, storing that in unsigned bits, and then the value is the reversed order as an unsigned integer. You see every single iteration, we're bit shifting mask by 1 so we can complete this operation. So let's compare what we've just determined by reading this code with our potential solutions. Here it says flips the bits and returns the number of 1 bits in num. That's not quite right because we're obtaining the value with power of 2 to the 31 minus I, so A is incorrect. Obtains the bit representation, returns the number of 1 bits, that's wrong. Reverses the bits and returns the number of 1 bits in num, that's wrong. Reverses the bit representation and returns the reverse result of the reverse bits in num. D is the correct answer.